In this video, we are going to show the PKCS11 Proxy in action. For the client application, we'll use a program to test the functionality of your HSM. However, this can be replaced by any other client-side application that uses an HSM through PKCS11. A few examples are Nginx. It can be configured to do TLS offloading for performance and security to a HSM using PKCS11. Another example is CyberArk. That one can also be configured to use PKCS11, and there's a lot of other major software that does some sort of cryptographic function that can be accelerated through HSMs using PKCS11. In this example, I will run our testing program, which is going to connect to Jellyfish, list a few partitions from different hardware manufacturers. It's going to authenticate, list objects within, and try to generate a key, encrypt, decrypt, generate some randomness, and a few other tests like that. First off, I'm going to show you the configuration. This is a standard configuration. Most PKCS11 enabled applications have something that look like this: CyberArk and Nginx. As you can see here in module, we are loading a linux.so file. In the Windows world, this would be a DLL. We support both Windows and Linux, as this is just standard for PKCS11. The partition would be a name or label, and the pin would be a Jellyfish API key. I'm just going to save this. We're going to run the test client application. Now, it's quite verbose. I've enabled all logins to show for this demonstration, but we'll start from the beginning. As you can see, the logs here with the Cogito Cryptoki log header are the actual DLL, the actual link library. As you can see, it starts up, connects to Jellyfish, and authenticates. Later on, our client application attempts to list slots. These are the slots that get returned from Jellyfish. We have 2 Luna slots or partitions, and also an Encipher slot here, which is what is being selected by our testing application. Then here it logs in, it lists a few objects. You can see the test passed. 59 objects were found in this partition. We also list the mechanisms supported by the partition. We also generate a key, 128-bit AES, do some encryption/decryption tests, and we generate some randomness. This is something you wouldn't worry about if you were running this using an existing application such as Nginx, or any other of the big names. You could also write your own PKCS11 applications using this PKCS11 library from Cogito. Next, I'm going to show you this test again, but with a different partition. I'm going to select the top one here. This is going to show that using the same client application with no drivers or firewall rules set up, I am able to use different hardware from the same application. I'm going to change the configuration file, change the partition, and then rerun the test. All the tests pass, same as before. There's a different number of mechanisms supported because obviously the hardware is different. It's a different HSM. There's a different number of objects because it's been used differently during testing. This is the partition that was selected. Cryptoki is often mentioned or found when looking at Luna HSMIS. This shows different partitions from different HSM manufacturers on different devices being used from the same client application with the same PKCS11 library file or link library DLL or SO file from the same client application with no changes required. No changes on the firewall, no changes on firmware or drivers installed. Nothing. This is one of the main benefits.